Now, officials have lifted a tsunami warning for the Philippines and Indonesia. It's after a 7.4 magnitude earthquake struck off the coast of the southern Philippines. The epicenter of the quake was off the island of Mindanao, and Philippines President Marcos has ordered emergency teams to deploy to the area. There are initial reports of some damage to buildings and disruption to power lines.
What if those 847 tremors weren't random but connected? What if they're quietly loading pressure onto a much bigger fault? Over the past few days, the Philippines has recorded 847 seismic events, sending shockwaves of concern through both communities and experts.
7 people have died following 2 earthquakes off the southern coast of the Philippines yesterday.
While many of these quakes were minor, scientists are closely analyzing whether this surge is triggering something far more dangerous: stress transfer along major fault systems. With the country sitting on the volatile boundary of the Pacific Ring of Fire, every cluster of tremors raises the same chilling question. Is this just seismic noise, or the buildup to the big one? Follow along as we track seismic updates and break down expert analysis in real time. The Philippines is not normal ground. Most countries sit on solid, stable ground. The Philippines does not get that luxury. This archipelago of over 7,600 islands is sitting right on top of one of the most geologically violent regions on the entire planet. It is called the Pacific Ring of Fire, and the Philippines is planted right in the middle of it.
There's one thing you need to know about the Ring of Fire. It produces 90% of the world's earthquakes.
The Ring of Fire is a massive horseshoe-shaped zone around the Pacific Ocean where tectonic plates are constantly colliding, sliding, and diving beneath each other. About 90% of the world's earthquakes happen here. The Philippines does not just sit near this zone, it is one of its most active members. What makes the Philippines especially unique is that it is squeezed between multiple tectonic plates at the same time. To the east, the Philippine Sea Plate pushes westward into the Philippine Mobile Belt at a rate of roughly 10 centimeters every year. That might sound small, but over decades, that pressure builds into something enormous. To the west, the Eurasian Plate adds more stress from the other side. The result? The Philippines experiences an average of around 14,000 earthquakes per year, according to data tracked by Volcano Discovery. Most of them are too small for people to feel. But the ones that people do feel, those tell a much bigger story about what is happening deep underground. What is stress transfer and why should you care? Now, before we go further, let's talk about something scientists call Coulomb stress transfer.
Coulomb criteria is if I unclamp a fault or increase its shear stress, failure is promoted. And if I do the reverse, if I clamp it further or relax this spring, failure is inhibited.
This is the key concept that makes the current seismic situation in the Philippines so worth paying attention to. Here is how it works in plain terms. When a fault breaks and an earthquake happens, the stress that was locked inside that fault does not just disappear. It has to go somewhere. It moves or transfers to nearby faults and segments of the Earth's crust. Think of it like squeezing a balloon on one end. The pressure does not vanish. It pushes out somewhere else. Scientists at the University of the Philippines National Institute of Geological Sciences have been studying this exact process in the context of the Philippine Fault and the Philippine Trench. Their research shows that when a large earthquake strikes, it can add stress to neighboring fault segments, essentially nudging those faults closer to their breaking point. According to published research from Temblor, the method works like this. Faults that experience stress increases after a nearby earthquake are considered more likely to rupture in the future. Those who experience stress decreases are temporarily less likely. Red zones on the Coulomb stress maps mean danger. Blue zones mean temporary relief. And right now, some red zones in the Philippines are getting very uncomfortable. The December 2023 magnitude 7.4 earthquake that started it all. On December 2nd, 2023, at 10:37 p.m., Manila time. A powerful magnitude 7.4 earthquake struck offshore, east of Mindanao, in the province of Surigao del Sur.
Tsunami alert has been issued after the Philippines was hit by a magnitude 7.4 earthquake, the second in less than 24 hours.
The earthquake happened at a shallow depth of just 26 kilometers, which made it hit harder and wider than deeper quakes typically do. This was no ordinary tremor. Research from the University of the Philippines National Institute of Geological Sciences found that this earthquake struck along an extinct oceanic fracture zone that was subducting, sinking, into the Earth's mantle beneath the Philippine Trench. The ancient tectonic scar was not supposed to move. But it did. And here is where things get really interesting. Within just days of that magnitude 7.4 event, a separate magnitude 6.8 earthquake struck about 70 kilometers to the northeast.
The powerful 6.9 magnitude quake hit the central Philippines at around 10 p.m. local time last night.
Scientists ran Coulomb stress transfer models and found that the magnitude 7.4 event had added stress directly toward the location of that second quake, essentially pushing it toward failure. One earthquake triggered another. The December 2023 sequence also produced a variety of unusual aftershocks involving both thrust fault and normal fault mechanisms happening within the same subducting slab. This is described in published research as rather unusual, and it showed scientists just how complex and unpredictable stress behavior in this region can be. The seismic swarm that followed, understanding those 847 events. After the December 2023 magnitude 7.4 earthquake, the region did not calm down.
It sent shockwaves through the region that brought down buildings, cracked roads, and left millions of people scrambling to safety.
Researchers noted that in the 2 months following that initial sequence, the number of earthquakes recorded in the Agusan Marsh segment area of the Philippine Fault actually surpassed the total number of earthquakes recorded in the entire year before it. That is a stunning jump in seismic activity. This is the broader context behind what alarm-raising headlines often describe as hundreds of seismic events occurring in compressed timeframes across the Philippines. The Philippines averages around 3,000 magnitude 3 or higher earthquakes per year, but following a major rupture event, concentrated swarms in specific regions can spike dramatically. When trackers tally all detected events, including smaller ones, the counts in active windows can rapidly climb into the hundreds. What makes this matter is not just the numbers themselves, it is the pattern. Seismologists track these swarms because they can indicate that stress is migrating along connected fault segments.
So straight after the earthquake, about 11 minutes after, there was a magnitude 6.7 aftershock. And generally for most earthquakes, on average, we expect the largest aftershock to be 1 unit of magnitude less than the main shock.
When earthquakes cluster along specific zones and keep increasing in frequency, it signals that the surrounding faults are absorbing redistributed stress from the initial large event. PHIVOLCS, the Philippine Institute of Volcanology and Seismology, monitors this activity 24 hours a day through the Philippine Seismic Network. Their earthquake bulletins are publicly accessible and updated continuously. If you want to track what is happening yourself, their live data is available at earthquake.phivolcs.dost.gov.ph. The August 2024 magnitude 6.8. The predicted earthquake. Now here is one of the most jaw-dropping parts of this story. After the December 2023 magnitude 7.4 earthquake, researchers from the University of the Philippines published a scientific model that predicted where the next significant earthquake was most likely to occur. And then, the earthquake happened exactly where the model said it would. On August 3, 2024, a magnitude 6.8 earthquake struck offshore Mindanao, about 48 kilometers east-northeast of the town of Lingig in Surigao del Sur.
6.8 magnitude earthquake that struck the southern Philippines. The quake yesterday hit the country's largest city on the second largest island of Mindanao.
This was almost precisely within the red zone on the Coulomb stress transfer map that scientists had published months earlier. The research, published in Temblor, confirmed that the August 2024 earthquake resulted from renewed movement of the same extinct fracture zone in the subducting slab that had generated the December 2023 event. The source fault from December 2023 had loaded stress onto the area, and 8 months later, the receiver fault finally broke. Scientists describe this as a direct demonstration of the predictive power of Coulomb stress transfer modeling. Within 4 days of the 3rd of August main shock, at least 6 aftershocks ranging from magnitude 4.8 to 6.2 followed. Fortunately, no major infrastructure damage or casualties were reported in this instance. But the scientific achievement here was remarkable. An earthquake was essentially forecasted using stress transfer science, and it came true. The Philippine fault, a 1,200-kilometer time bomb? The Philippine fault zone is one of the longest active fault systems in the world. It stretches more than 1,200 kilometers through the heart of the Philippine archipelago, running from the northern island of Luzon all the way down through the Visayas and into Mindanao. Scientists have described it as carrying the left lateral component of the oblique convergence at the Philippine Trench, moving at an estimated slip rate of 25 to 35 millimeters per year, depending on the segment. On Leyte, that slip rate is approximately 35 millimeters per year. On Luzon, it slows to about 20 millimeters per year. But even at those rates, the energy accumulation over decades is staggering. And published research from 2025 by scientists at the University of the Philippines shows that some segments of the Philippine fault are currently sitting inside long-term zones of Coulomb stress increase, meaning stress has been loading up on them for decades without a major release. These quiet segments, what geologists call seismic gaps, are particularly concerning. A seismic gap is a stretch of a fault that has not had a major earthquake in a very long time. The historical record shows that segments of the Philippine fault in eastern Mindanao, particularly near the Agusan Marsh area, have not produced a major magnitude 7.0 or greater event in the documented record. That silence is not reassuring. In seismology, silence often means something is building. According to a May 2025 study from the University of the Philippines team, published in Temblor,
Temblor has just published a new analysis of the interaction of the magnitude 7.8 and magnitude 7.5 earthquakes that struck in February.
Coulomb stress transfer analysis of earthquakes from 1973 to 2023 along the Philippine fault shows areas of stress increase on multiple segments. The researchers specifically noted that quiet segments should be treated with caution because they may simply be waiting. September and October 2025, the Philippines woke up again. The year 2025 brought a sharp reminder that the Philippines is never far from the next big shake. On 29 September 2025, a magnitude 6.9 earthquake struck the province of Cebu at 10 p.m. local time.
Around 70 people are dead after a powerful 6.9 magnitude earthquake rocked the Philippines overnight.
It killed 72 people and became the deadliest earthquake in that region since 2013. Rescue teams found bridges impassable, local hospitals unusable, and communications knocked out in 3 municipalities. Then, just 11 days later, on October 10, 2025, 2 large earthquakes struck southeastern Mindanao and Davao Oriental in the same day. A magnitude 7.4 hit at 9:43 in the morning. Then, less than 10 hours later, a magnitude 6.9 struck at the same location that evening. 2 major earthquakes in one day at nearly the same spot. Scientists ran Coulomb stress transfer tests on the Cebu and Davao earthquakes and found that the 2 separate clusters, Cebu and Davao, were not directly related to each other. They were generated by different fault systems that are not physically connected. But within the Davao Oriental sequence, stress from the morning magnitude 7.4 was analyzed in relation to the evening magnitude 6.9. The proximity in time and location made the relationship between those two Davao events a subject of active investigation. By the window between September 25 and October 9, 2025, the Philippines had recorded more than 2,400 earthquakes across the country. That is the kind of concentrated seismic activity that makes scientists sit up straight and start drawing stress transfer maps all over again. What is the big one, and where does it come from? The phrase "the big one" has been used in the Philippines for years. But what exactly does it mean, and is it real science or just a scary label? It is a very real science. The big one refers specifically to a projected magnitude 7.2 earthquake along the West Valley Fault, which runs directly through Metro Manila and several surrounding provinces. This fault passes through Quezon City, Pasig City, Marikina City, Taguig City, and Muntinlupa City, cities that combined hold millions of people. It also extends through the provinces of Bulacan, Rizal, Laguna, and Cavite. According to PHIVOLCS, the West Valley Fault produces a major earthquake roughly every 400 to 600 years. Its last significant movement was recorded in 1658. If you do the math on the lower boundary, 1658 plus 400 years, you land at 2058. PHIVOLCS.
The big one, we say that it happens every 400 to 600 years. And the last time it moved was in 1658. So if you consider the lower boundary, which is 400 years, so 1658 plus 400 years, that would be 2058.
Director Teresito Bacolcol has stated publicly that the Philippines is already within the expected window for the next movement of this fault. The critical word here is window. PHIVOLCS is not predicting that the big one will happen next week or next year, but the fault is well within its expected cycle, and every passing year adds more stress to a fault that last snapped over 360 years ago. The West Valley Fault is described by the World Bank as posing the most serious seismic threat among all earthquakes. What would the big one actually do to Metro Manila? If the West Valley Fault ruptures at magnitude 7.2, what happens next is something PHIVOLCS has studied in frightening detail. A 2013 risk analysis study by PHIVOLCS and the University of the Philippines. Diliman Institute of Civil Engineering projected that a big one scenario could result in around 37,000 fatalities and approximately 605,000 injuries, ranging from slight to life-threatening in Metro Manila alone. A separate PHIVOLCS study projected that at least 168,000 buildings could collapse across Metro Manila and surrounding provinces. To put that in perspective, Manila's residential areas are packed with older structures that were never designed with modern seismic codes in mind. A magnitude 7.2 event along the West Valley Fault is expected to generate intensity 8 shaking, officially described as very destructive. At that intensity, standing upright becomes nearly impossible, and even reinforced structures take serious damage. Beyond the direct shaking, the big one would trigger a chain of secondary hazards. Liquefaction, where the ground temporarily behaves like liquid, is a major risk in many low-lying and reclaimed areas of Metro Manila. Ground ruptures, landslides, and potential tsunami risk from offshore trenches are all part of the projected scenario. The World Bank has noted that in some affected areas, ambulance access times after the earthquake could be 10 times longer than normal, cutting off roughly 1.1 million people from hospital access. The movement of offshore trenches, particularly the Manila Trench to the west, could also generate a separate magnitude 8.0 earthquake, with ground shaking at intensity 7 and 8 across wide parts of Luzon. This is not the same as the West Valley Fault scenario. It is an additional, independent risk that the Philippines carries simultaneously. The stress transfer question: could distant quakes load the West Valley Fault? Here is the question that is worth asking out loud, and scientists are thinking about it too. Given that we now know large earthquakes in Mindanao can transfer Coulomb stress to nearby fault segments, Could a major earthquake far to the south ever affect the stress environment around the West Valley Fault in Metro Manila? The straightforward scientific answer is that the Cebu and Davao earthquakes that happened in October 2025 were found by CST modeling to be unrelated to each other, and the West Valley Fault operates on an entirely different fault system, far from the Philippine Trench earthquakes in Mindanao. Vivolc's director Bacolcol confirmed in October 2025 that recent earthquakes in various parts of the country, La Union, Zambales, Cebu, Surigao, and Davao, came from different earthquake generators and are not connected to the West Valley Fault. But here is the honest scientific nuance. Stress transfer science is complex, and it operates across a range of distances and timescales. Researchers at the University of the Philippines have shown that cumulative Coulomb stress changes from 50 years of earthquakes along the Philippine Fault have loaded certain segments measurably. The further question of whether stress can migrate along connected fault networks toward the Manila area is an active area of research, not a closed case. What we can say with confidence is this: the West Valley Fault does not need external help to be dangerous. It has been building its own energy for over 360 years. Whether nearby seismic activity adds anything to that stress, even marginally, is a legitimate scientific question that deserves continued study. The seismic gap problem. Silent faults are not safe faults. One of the most sobering findings in recent Philippine earthquake science comes from a study published in Temblor in May 2025. A team from the University of the Philippines traced the Coulomb stress history of the entire Philippine Fault from 1973 to 2023. They mapped 64 earthquakes of magnitude 5.0 or greater across 5 decades and modeled how each one changed the stress environment for neighboring segments. Their findings identified multiple segments of the Philippine Fault currently sitting inside long-term stress increase zones, areas that have been accumulating transferred stress from nearby earthquakes for decades. Some of these segments correspond to areas with very little recent seismic activity, which sounds like good news, but is actually a warning sign. The Agasan Marsh segment and nearby sections of the Philippine Fault in eastern Mindanao fall into an identified seismic gap, a section of the fault squeezed between the areas that ruptured in historical earthquakes in 1879 to the north and the 1891 and 1893 events to the south. A seismic gap does not mean the fault is inactive. It often means the fault is locked and building energy without releasing it in smaller, manageable quakes. The research notes that segments in this gap have experienced stress increases based on the CST modeling, which means they were brought closer to failure by previous earthquakes. Scientists are not saying a rupture is imminent, but they are saying these quiet sections of the fault deserve serious monitoring and should not be treated as safe just because they have been quiet. Is the Philippines prepared for what is coming? The honest assessment from scientists, government agencies, and international organizations is that the Philippines is not fully prepared for a Big One scenario. The Office of Civil Defense has publicly acknowledged that significant gaps remain across 3 key areas: engineering solutions, emergency response capacity, and overall public preparedness. On the engineering side, recent studies show that many buildings in Metro Manila do not meet earthquake safety standards. Following the September 2025 Cebu earthquake, it was noted that even homes built specifically as disaster-resilient structures for Typhoon Haiyan survivors were badly damaged. If buildings designed for resilience can crumble in a magnitude 6.9, the implications for older, non-engineered structures in Metro Manila during a magnitude 7.2 are deeply concerning. On the response side, the government has made meaningful efforts. The nationwide simultaneous earthquake drill program has run quarterly since 2006. The World Bank approved a $300 million loan in 2021 for a seismic risk reduction and resilience project targeting Metro Manila, which includes retrofitting public buildings and improving emergency response capacity. Manila Mayor Isko Moreno ordered citywide simultaneous earthquake drills across all 896 barangays in late 2025, which reflects the kind of local action that can make a real difference. The Philippines and Japan have an ongoing collaboration on earthquake impact studies. The original 2004 JICA 5 MMDA earthquake impact study is planned to be revisited in 2026. Japanese expertise in earthquake science and preparedness is among the best in the world, and this partnership has the potential to sharply update the country's risk projections and resilience planning with more modern data and modeling techniques. The 180 active faults nobody talks about. When most people talk about earthquake risk in the Philippines, they focus on the West Valley Fault because it runs through the most populated city in the country. But PHIVOLCS Director Bacolcol has publicly stated that the Philippines has 180 active faults spread across the archipelago. That means nearly every major island group carries its own set of seismic threats. In the Visayas, the Masbate fault system produced a magnitude 6.6 earthquake in August 2020 and a magnitude 6.1 just 2.5 years later. Research showed that the 2020 earthquake had transferred stress toward where the 2023 event eventually ruptured, another documented example of stress triggering on a regional scale. In Mindanao, the Philippine Trench, the Cotabato Fault System, and various segments of the Southern Philippine Fault create a deeply complex seismic network. The Cotabato Fault System consists of a mix of northwest-southeast trending left lateral faults and northeast-southwest trending right lateral faults, which means stress can travel in multiple directions depending on which fault segment moves. In Luzon, beyond the West Valley Fault, active reverse faults create zones of peak ground acceleration that are wide enough to affect major urban centers. Areas close to the Manila subduction zone to the west of Luzon carry their own elevated hazards separate from the Valley Fault System. Simply put, there is no part of the Philippines where earthquake risk can be completely dismissed. What science can and cannot tell us about the next big earthquake. Let's be completely honest about what earthquake science can and cannot do. Scientists cannot predict the exact day or hour of an earthquake. No technology in the world can do that with certainty. What science can do and is getting steadily better at is identify which areas are most at risk, which faults have been loaded by neighboring earthquakes, and where the probability of future rupture has increased. Coulomb stress transfer modeling is one of the most powerful tools available for this kind of analysis. The fact that researchers at the University of the Philippines successfully forecasted the location of the August 2024 magnitude 6.8 earthquake months in advance, based purely on stress transfer calculations from the December 2023 event, is an enormous achievement. It demonstrates that this science works, even when earthquakes behave in unusual ways. PHIVOLCS continuously updates earthquake hazard assessments based on new data.
PHIVOLCS Director Renato Solidum, this hazard and risk assessment app is very useful in different real-life situations like when buying a house or constructing a building.
Their monitoring network across the Philippines, combined with international partnerships and university research, provides a level of scientific oversight that is genuinely world-class. The challenge is not a lack of scientific knowledge. The challenge is translating that knowledge into building codes that are actually enforced, emergency plans that are truly practiced, and communities that understand their real risk. One honest note worth making: earthquake probability science deals in likelihoods over decades, not certainties over days. When scientists say a fault is ripe for a major earthquake, they mean the risk is elevated and persistent, not that an earthquake is hours away.
Powerful earthquake in the central Philippines just last week, which killed dozens of people and caused really extensive damage. So I think the authorities will be on alert to see just how bad the damage is this time.
The appropriate response to that kind of risk is sustained, organized preparedness, not panic. What every Filipino and every watcher can actually do. The science tells us the risk is real and it is not going away. The good news is that preparedness is not complicated. The actions that save lives in earthquakes are well understood, inexpensive, and possible for most families and communities to do right now. At the household level, FIVOLCS and the Office of Civil Defense recommend having a go bag ready with emergency supplies, important documents, medicine, and water. Families should identify a meeting point outside the home in case they are separated when a quake strikes, because mobile phone signals will likely be unavailable immediately after a major earthquake. Every person in the house should know the difference between a safe spot and a dangerous one when the shaking begins. At the community level, participating in the nationwide simultaneous earthquake drills that FIVOLCS and local governments organize every quarter is genuinely useful. The purpose of these drills is not just to practice duck cover and hold, it is to test communication systems, identify gaps in evacuation plans, and build the kind of muscle memory that can save lives in a real event. Barangay-level planning matters enormously in the Philippines because local units are typically the first responders before national agencies can arrive. At the national and policy level, the call for more rigorous enforcement of building codes is one that researchers, engineers, and disaster experts have been making for years. The 2019 magnitude 6.1 earthquake in central Luzon cost 18 lives and roughly 505 million pesos in damage, and that was a moderate quake. A magnitude 7.2 along the West Valley Fault will be in a completely different category. Engineering solutions, retrofitting vulnerable structures, stricter building permits, and infrastructure audits are the kinds of investments that pay off when the ground finally moves. The Philippines lies on one of Earth's most active seismic zones, where frequent quakes transfer stress to nearby faults. The long, quiet West Valley Fault could produce a devastating 7.2 magnitude earthquake in Metro Manila. Science shows preparation works through stronger buildings, drills, and readiness before the next major rupture strikes. Drop your thoughts in the comments. Are you living near a fault zone? Have you ever been in a strong earthquake? And do you think the Philippines or your own country is doing enough to prepare?